All right, in this video, we're going to be covering a more complex, honestly, a pretty complex vulnerability here with smart contracts, Solidity, when it comes to Ethereum, smart contracts. So we're going to actually need to break this one down. This one gets super complex, and there's some prerequisite knowledge that we're really going to need. So let's just get right into it. What's up, guys? This is Ryan from elevatecyber. We're covering the delegate call in this one, but we're not going to go over the full thing in this one because we got all kinds of crazy stuff here, really. And it gets pretty high level, and there's a lot of prerequisite knowledge on Solidity and how things are working almost under the hood, really, to understand this one fully. So we're going to be covering the prerequisite knowledge mostly in this one, is we're going to be honing in on. But yeah, the delegate call. So in Solidity, you have a couple opcodes that are pretty similar, but they have different nuances. So you got call and delegate call. Now, they're explaining here basically the difference between these two opcodes is that the call opcode is run in the context of the external contract / function, whereas the delegate call opcode, while it's identical to the standard message call, the difference is the code is executed at the target. The code that is executed at the targeted address is run in the context of the calling contract, and also the fact that message.sender and message.value remain unchanged. So you can still use message.sender and message.value as you would normally, but the context of the calling contract is actually going to be run in the targeted address. This is the important distinction to know, and it's actually what opens it up for vulnerability. But so what you can have is you can have a third-party contract that you're using, like, for example, a library. And that library could be completely vulnerability-free. It could be a secure library. However, if you call that library using a delegate call, the fact that you are giving it, the context of the contract is what it's going to be run as. That simple fact there may result in code execution. So this is I should have said this from the start, honestly, but this is a very serious vulnerability. If it is in your smart contract, you could be completely hacked, right? An attacker could get remote code execution on your system. So this is definitely one of the most serious vulnerabilities that we have encountered so far in our journey here. So the context of the external, the context in which it's run is extremely important when it comes to the delegate call here. Now, like I said, there's some prerequisite knowledge we need to know here. One thing is the Kikak hashes. That's a hash that's very common, or SHA-3 as you might sometimes see it written. This is a very common hash when it comes to Solidity smart contracts. And as you see here with require function here, calling the Fibonacci library, the delegate call, fibsig. Now, fibsig was a variable that was the first 4 bytes of the Kikak hash of a particular function that we want to call. So if all this sounds crazy, just know that this is a hash of a string, and this is the function you want to call. And the second value is what you're actually passing in. So you're actually passing in the withdrawal counter. Now, I know I skipped a lot of stuff here. We're going to really be going line by line in a future video, but I just want to give you some basics. And now, beyond that, you really need to understand a couple things, right? I was trying to hammer this home, but I thought this post really said it well. As in addition, the difference between call code, and delegate call. Now, call code, I believe, is deprecated from what it sounds like here. And says delegate call basically says I'm a contract and I'm allowing or delegating you to do whatever you want to my storage. So all you security guys, probably alarms are going off in your head when you're hearing this. But yeah, it is as serious as it sounds. So Another thing that's very important to understand is the layout of state variables and storage. Unfortunately, the link that they provided here is not valid anymore, but it was from the Solidity documentation. I pulled that up. It was a little bit, I think, still a bit more complex. So I found this blog post here explaining it. Solidity storage layout for proxy contracts and diamonds. And it does give a good overview, I believe. So it says storage layout is how and where state variables and contracts are actually stored in contract storage. So basically what that means, before we even get into that, I want to just backpedal here for a second and explain. Let's see. He stated it pretty well in here earlier. Basically, yeah. So before discussing the actual issue, quick detour to understanding how state variables, also known as storage variables, actually get stored in contracts. So state or storage variables are variables that persist over individual transactions, right? So these are variables that you can actually use them between different contracts. And so they're placed into slots sequentially as they are introduced in the contract. Okay, so starting at zero indexed, basically, right? And there are some complexities here, which we're about to get into in a second, right? So just know that, hey, these are variables that you can use between different contracts, and they are placed sequentially starting from zero, right? And so storage layout isn't something we have to think about when writing a regular contract. Hence why I was saying this is one of the under the hood things that you just need to understand about Solidity. So it's taken care of by the Solidity compiler. So when writing a proxy contract or diamond, you have to be aware. So this is more talking about that, but there's still, I believe that the fundamentals do apply here. And if I'm completely off, let me know in the comments section below, right? Because I'm learning this stuff alongside you guys. So here they're describing the layout of state variables and the contract storage, and they're giving a very simplified explanation. This is the part that I thought was really valuable in breaking this down a little bit better than the Solidity docs did. It was pretty high level to understand, it felt like. So storage layout for state variables begin at position 0, right? And increment, sequentially, basically. So the first state variable stored position 0, second at 1, 2, so on. You get the point there. Now each struct or array element uses the next storage position as if each one was defined separately on its own. And so dynamic arrays and maps also use the next position in storage, but due to their dynamic nature, store their values at positions based on hashes of their storage position and keys, right? Which makes sense, right? If you have a mapping, right, it is an unordered storage variable, right? It's basically unordered, right? So there is no sequential order as you would have with the other elements. So it makes sense that it's more based on their values at positions based on the hashes, right? And the positions and keys. So the main thing to understand is that storage layout begins position 0. So, that's pretty much what you need to know here. The rest of this stuff, that's also showing you unstructured based on the keys. Not too much to understand beyond that when it comes to this stuff. So really, with that out of the way, we're going to break this down in a future video line by line here. We can go over what they're using as I think I skipped over it. The library, right? So Fibonacci numbers, just to understand, this Fibonacci sequence is basically, you start at a number and you go up to n, whatever you're calling n is your ending number, right? And so you'll say you start at 1, right? You'll have 1 plus 1, that's equal to 2, right? So then you'll do 2 plus the previous number. So 2 plus 1 is 3. 3 plus 2 is 5, right? And, so on and so forth. That's basically the Fibonacci sequence. And so this contract here that they're using as their third-party contract is just basically it's just a function that implements the Fibonacci sequence. And so it will take a start, like you'll set where your starting number is, and then you'll also set what value n is, your ending number. And based on that, it will do the Fibonacci sequence. And so this contract here is not vulnerable. However, when it's run with the delegate call in the context that we'll see in this contract later on in the next video, that is what actually makes it vulnerable. Because you got to remember, the delegate call is actually going to delegate everything to that contract. And so if you do that with that function and you're not aware of how, what these variables are being set at, like what address it's using, then that could introduce some pretty serious stuff, as we will see. So hopefully this video at least gave you some insight on some of the inner workings under the hood stuff that's going to be really helpful in understanding this vulnerability. For example, the layout of the storage variables, right? As well as the delegate call and the difference between delegate call and the call opcode. So with that being said, we will get right into it in a future video. If you're really eager on this Solidity smart contract vulnerability stuff, check out some of the previous videos, cryptocurrency and security, on the screen now. And yeah, you can watch some where we really went through start to finish on a lot of these. And yeah, didn't want the video to get too long. I mean, we're already at 11 minutes here. If I tried to do the whole thing, it would be insanely long. So want to keep it digestible for you guys. I'll see you guys right over in those videos. Thanks for watching.